Hi grade 11s. Now that we've covered the 6 topics which cover all the concepts that we need to do in analytical geometry, we need to look at some past paper questions which brings it all together. Analytical geometry is a wonderful section, but it's really important that we cover past paper questions that have all the concepts in kind of like one picture. So we've got 4 examples to look at, and hopefully by the end of that and some past paper work, we will feel really confident in this section. So first things first, example 1 says FG has the equation of 4y plus 5x equals 3. Now this was from a past paper, and notice they haven't actually written the equation on, so I like to label as I find stuff out. I like to label it in on graphs, because otherwise when I answer the next question I forget that I might already know stuff. Now the first thing I notice about this particular equation is it's not in standard form, and unless an equation is in standard form it's not useful to me. So I'm going to, by standard form, I mean I should have y all by itself. So I'm going to subtract 5x on both sides, and then I'm going to divide by 4. Don't forget that when you divide by 4, you divide everything by 4. So both those numbers on the right hand side get divided by 4. Great, let's look at a question. Determine the equation of AB. Okay, well that's got nothing to do with this line FG, so let's look at AB, and what do you know, they've given me 2 points on the graph. Now that's wonderful, because it means that I can immediately go into finding my gradient. In all questions you don't have to write down the equation for gradient. You're welcome to go straight to substitution. So especially in an exam where I don't really want to waste too much time, if I call this point number 2 and this point number 1, don't forget that it's y2, so that's 6 minus y number 1, which is negative 2, all divided by x number 2 minus x number 1. Again, this is like a 2-mark, calculation, so we don't actually generally show any working. What we would do is just put that in your calculator and let the calculator work it out for us. So I get 4/5. So you don't have to show any working other than that. Now that means my equation so far is y is equal to 4/5 mx plus c. Now always pause and think, does that make sense? Does a gradient of 4/5 make sense in this picture? And it absolutely does, because the graph is slanting upwards. Now what I need to do is I need to substitute in a point and solve for c. It doesn't matter whether you substitute in point 1 or point 2. I personally would probably substitute in the 4, 6, point b. Don't forget that the y is 6 and the x is 4. And the reason why I'd put in that is that it didn't have any negatives, and I don't really like negatives. So basically I'm going to say that this is 16 over 5. Again, don't forget this is technically 4 over 1. So 16 over 5, and then we just use our calculator. So if I take 6 and I minus 16 over 5, I get 14 over 5 is equal to c. And so finally, I'll write it over here. My equation is 4 over 5x plus 14 over 5. Great. Now I personally would go and write that in, because you never know when I need it. So this is 4 over 5x plus 14 over 5. Now actually the moment I found out that gradient, I looked at this and I thought, 4 over 5 negative 5 over 4, that's very interesting. Now you'll notice that there's a relationship between those two. Those two, basically the one is the other one swapped around and changed the sign. Now I know if I see that pattern that these lines are perpendicular, they're at 90 degrees to each other. So nice to just pick up things along the way. So determine the coordinates of P. Now what is P? P is the point of intersection of these two lines. I'm fairly used to finding out points of intersection. So basically I'm finding out the point of intersection between negative 5 over 4 x plus 3 over 4, which was the line given to me, and now this line is 4 over 5x plus 14 over 5. So not a particularly nice question because it has fractions, but do not shy away from fractions. You have a calculator, and so that's all we need. So I'm going to equate these two lines. Remember, when you're finding a point of intersection, you equate the two lines together. And now it's horrible, but I'm basically going to multiply by the LCD. So we haven't done fraction equations in a while, so the LCD of 4 and 5 is 20. So I'm just going to multiply everything by 20. So every term gets multiplied by 20. Now, I'm not too sure how rusty we are, but what we say is well, 4 goes into 25 times. So this actually becomes negative 25x, because 5 times negative 5 is negative 25. Then 4 goes into 25 times, so this becomes plus 15. 5 goes into 24 times, so this becomes 16x. And 5 goes into 24 times. And 4 times 14 is 56. So a little bit messy. So now negative 25, if I now minus 16 on both sides, I get negative 41x. And if I minus 15 on both sides, I get 41. And so what started off as a fairly mean equation actually lands up with a fairly nice answer. So negative 1 for x once I've divided by a negative 41. And that's wonderful. So p is the point negative 1 something. Now, how do I know what that something is? Well, basically, I either need to put negative 1 into there or into there, and it does not matter which one, because you will get the same answer, because that's the whole point. It's a point of intersection. So often what I do, just to check if I've got this right, is I put negative 1 into both. Because if I get the same answer, I just did it on my calculator quickly. If I get the same answer, then I'm confident that I haven't made a mistake. So I did exactly that. I put it into both, and I got 2 either way, which means I know I'm right. Now again, if this is me in an exam, I would actually go write this in. Also look at the picture. We don't auto scale, but p would have to have a negative x value and a positive y value. We do draw accurately, just not particularly to scale sometimes. Great, so moving on. Next question. Show that the lines are perpendicular. Now, I'd already kind of guessed they were perpendicular. Now, the most important part of this question is that it says show that, which means this is like a proof. So what I would do is I would say, well, the gradient of fg is, and we worked it out to be negative 5 over 4, and the gradient of AB, which we calculated, was 4 over 5. Therefore, the gradient of fg multiplied by the gradient of AB, notice how you use these subscripts, really important, is equal to negative 5 over 4 times 4 over 5. Please don't ever write m times m, because m times m implies they're the same thing. So we use subscripts all the time to explain which line we're talking about. Now, I don't know if you remember, but to show that lines are perpendicular, this is what you have to do. You have to show that the two gradients multiply together to give you negative 1. You mustn't just state it. It says show, which means prove that. So I would write out exactly this. It's probably a 3-mark question, but because it says show or prove, you've got to explicitly show that those gradients multiply together to give you negative 1. Right, determine the distance of AB. Well, we have the distance formula. Again, I often don't write down the formula, I just go straight to substitution. So just for this time, I'm going to write down the formula because we don't have it in front of us. You basically subtract the x values and subtract the y values and square them. So it doesn't matter which one's point number 2 and point number 1. I'd already labeled that point number 2 was 4, 6, so 4 minus negative 6 plus, and this is 6 minus negative 2. And we definitely don't show any working after this. You can just put that straight into your calculator and let your calculator do the work for you. Now, unless otherwise stated, you can give the answer in what we call simplest third form, which is that. Or, if it doesn't state, you could give it rounded off to 2 decimal places. It doesn't matter, but just make sure you read the instructions carefully. Now the question says, determine the equation of the perpendicular bisector of AB. So perpendicular bisector is a line perpendicular to AB. So I'm just going to draw AB for us again. B was the point here, which was 4, 6. A was the point negative 6, negative 2. And just so we remember, this gradient was 4 over 5x plus 14 over 5, if my memory is correct. Now the perpendicular bisector, don't forget, is the line which goes straight through the middle, because bisect means to cut in half. So I'm going to label that as M. So bisector means cut in half. and perpendicular basically means at 90 degrees. Now that's wonderful, because we already know the equation of, well, the gradient of the perpendicular line. The gradient of the perpendicular line is swap the fraction round and change the sign. Now I know that because FG was perpendicular. So immediately my perpendicular bisector is going to have a gradient of negative 5 over 4x, but I don't know my y-intercept. So the question is, what is a point on this line? The only point on this line that I know is this midpoint. Now how do I find midpoints? Again, we don't show working necessarily. You add your y values together and divide by 2. Add your x values together and divide by 2. So I wouldn't probably show this in an exam, but these are our notes. So add my x values together, divide by 2. Add my y values together and divide by 2. So my midpoint would be negative 1, 2. Now, if I just scroll up for a second, oh my word, is that this not P? So when they say determine the perpendicular bisector of this line, guess what the perpendicular bisector is? It is FG. So now that I've recognized that, I shouldn't waste any time. So therefore, FG is the perpendicular bisector because it goes through that point and it has that gradient. So it's negative 5 over 4x plus 3 over 4, if I'm remembering correctly. So quite a nice one, because you had to do a little bit of work to figure out that FG actually was the perpendicular bisector. Right, now that's the end of example 1. Good revision of midpoint, distant, gradients, perpendicular lines. Hopefully we're feeling a little bit less rusty. Let's look at example 2. Example 2 says, if LMNP is a parallelogram. Now LM, I don't see an N. Now look at the way in which it's named. It's always named in the order in which they're connected. So LM, N would be somewhere there, and P. So N is somewhere up there, which is good to know. Determine the coordinates of N. Now, there's the easy way and the hard way to do this. I always use the shortcut, which I know I've discussed with you before, which is if I just take, for example, from L to P, I clearly went across from L to P and I went up. I went across from negative 1 to 4, so I increased that by 5. I went up from negative 1 to 0, so I increased that by 1. Put a plus sign there. Now that means from M to N, I must do exactly the same translation because these opposite sides are equal and they're parallel. So I must increase my x coordinate by 5, increase my y coordinate by 1. So if I take negative 2 and I add 5, I'm going to get to 3. And if I take 4 and I add 1, I'm going to get to 5. So this is generally a 2-mark question because literally you'll probably have scribblings all over your paper, but there's one answer. It's 3, 5, and there's no working. Now, who said that I had to use L to P? I could have gone, how do I go from M to L, or vice versa? So if I go from negative 2 across to negative 1, I'm clearly increasing the x value by 1, but I'm going down from 4 to negative 1, so I'm subtracting 5. So from N, I'm going to have to go across and down, or you could have thought of it as down and then across, it doesn't matter. But clearly I'm going to have to be subtracting 5, and I'm going to have to be adding 1. So what do I have to add 1 to get to 4? I must have started at 3. And what do I have to subtract 5 from to get to 0? It must have been 5. So obviously you don't have to check both ways. Pick whatever way makes sense to you, but both of them will work. So far I have a lot of scribblings. So let me just erase all my scribblings so that we can see a little bit more of our parallelogram to work with. I'll just erase that part. Right, let's have a look. Next question says, show that, again with this show that, the diagonals are perpendicular. So one of the diagonals is already drawn in, it's there, and so my other diagonal will be there, and they want me to show that those cut at 90 degrees. Now, there's only one way to show that lines, well, there's not one way, but the shortest way to show that lines are perpendicular is to show the gradient of PM multiplied by the gradient of Ln is going to equal to negative 1. That's what I want to show. I wouldn't write that. That's it going through my head. I need to show that these gradients multiply. Now, I don't have any of these gradients. So I first have to work out the gradient of PM. Please, again, use these subscripts. There's lots of lines here. So if you just start writing M equals, we don't know which one. I definitely wouldn't show the formula. I would just go straight to substitution. So if I start with M, the Y value is 4 minus P is 4 minus 0 over negative 2 minus 4. Change in Y over change in X. Again, you'd use your calculator. So that's negative 2 over 3. And what's the gradient of Ln? Now, if you couldn't work out n, let's say you had no idea what was going on in A. Now in B you want to use a coordinate and you don't have it. This is going to sound ridiculous, but make up the coordinates in A. Go and do your best thing and just say n is, I don't know, 8, 5. It doesn't matter. Because after that, we will continued accuracy mark, so we'll method mark all the other questions. So you can't do B without A. So if you can't do A, under question A, you try your best and then you just make up an answer. And then you will mark your answer from then on out. So now the gradient from L to N would be 5 minus minus 1 all over 3 minus minus 1. So that becomes 3 over 2. Now I need to say therefore, remember this is a proof, so you want to show it quite explicitly. So the gradient of PM times the gradient of Ln is equal to negative 2 over 3 times 3 over 2, which, what do you know, it's negative 1. Therefore, PM is perpendicular to Ln. Now this is a really nice question because this question is playing on this idea of quadrilaterals, because now I know it's a parallelogram and suddenly I've got this extra bit of information of this 90 degrees. Now there's only a certain class of parallelograms that have diagonals which intersect at 90, and that is a rhombus. So the moment I see this, I'm just making a note to myself, this means that LMNP is a rhombus. Now if I look at the next question, it now says show that LMNP is a square. Now a rhombus is any four-sided shape. I'm just going to draw myself a rhombus. Oh, that looks terrible. It's a four-sided parallelogram, but all four sides are equal. The corners are not necessarily 90, but our diagonals intersect at 90. So no one has said that this is a square yet, but I do know that it's a rhombus. So my first statement that I would make is that LMNP is a rhombus. Don't forget that a square is a type of rhombus. Now why is it a rhombus? It is a rhombus, so because, that's the symbol of because, it is a parallelogram, or you can say a palm, and the diags bisect at 90 degrees. Now I say they bisect, I could also say they intersect, but I know they bisect because the diagonals of a parallelogram cut each other in half, so they bisect. So I know it's a rhombus because it's a parallelogram and my diagonals bisect at 90. So now there's only one extra thing I need to show in order to say this is a square. So a square, all I have to do now is show that this is also a rectangle. Now what are my properties of my rectangle? Properties of a rectangle is that your diagonals are equal. So I could find the distances of both diagonals and prove they're equal. Or I could prove that one corner angle is 90. So it really doesn't matter. They're the same kind of length of calculation. Now I've already found a whole bunch of gradients. So why don't I do some distance calculations just for fun. Notice that if you couldn't find n, if I didn't know what n was, or if I then just guessed n, it would make sense to try and show that this corner is 90, because then you don't have to use n's coordinate. So sometimes it is better to stick with things that are given to you, in which case you would find two gradients and show that they multiply together to give you -1, and therefore this corner angle is 90. So I'm going to do some distance calculations just to practice. So if I looked at the distance from M to P, again we don't show the formula necessarily, so that would be -2 minus 4 squared and 4 minus 0 squared. We don't show any working. We literally just pick up the calculator, plug those things in, and I get 2 root 13. So now I look at the distance from L to N, which is -1 minus, and my N value is 3, 5. So it's -1 minus 3 squared plus -1 minus 5 squared, and I get 2 root 13. So therefore, remember, this is a show, this is a proof, so you've got to like kind of spell things out. So therefore, the distance from M to P is equal to the distance from L to N. Therefore, LMNP is actually a rectangle. Because, in brackets, why? And you just explain why. Because my diags are equal. And therefore, actually, LMNP is a specific type of rectangle. It is a square. And why is it a square? It's because it is a rhombus and a rectangle. So don't forget that a square is just a mixture of the two. So a really nice question, because they gave you enough information to start with, so it wasn't like an 8-mark prove this is a square. They kind of led you there, which is a nice question. Great, on to question D. Question D is all about, finally, we've got the size of this angle beta. Now, probably if I'd looked ahead of this, if I knew I was going to be finding the angle of beta, it might have made more sense to prove that this corner was 90, because I'm going to need the gradient of ML, I'm sure. So let's have a look. Beta is in this corner here. Now, the moment I see an angle question, I go and label in all my angles of inclination, because they might help me. So I'm going to call that alpha, and I'm going to call this angle there theta. Now, do alpha and theta help me get beta? So let me just say this again. The moment I see an angle question, I go label in all angles of inclination to see if they help me. So if I look at alpha and theta, I think that will help me find beta, because I could do exterior angle of a triangle. I could say that alpha equals beta plus theta, exterior angle of a triangle. Or I could find this angle here, adjacent angles, triangle. Let me say that again. Adjacent angles in a straight line, and then do some angles in a triangle. So actually, absolutely, if I can find alpha and theta, my life is going well. So it might have made more sense for me to find the gradient of LM in the previous question instead of doing distance, but oh well. So the gradient of LM is change in y, so 4 minus 1 all over -2 minus 1. So that gives me a gradient of -5. So therefore, tan of what I've labeled as theta. Now don't forget, in an exam, you would have this diagram as part of your answer sheet. So you can just label theta in the picture. So tan of theta would be -5. Now don't forget, we shift tan of -5 and you get a negative angle, which is not what you want. So if you add 180, I get 101,3. Now keep a couple of decimal places because the rounding might get affected. So don't forget, shift tan, and I actually got like -78, something, and so I had to add 180. Now that does look obtuse, so that makes sense. Now the second part is to look at the gradient of MP, which I'd already worked out. So try to label things on your picture when you work them out. If you work out a gradient, label it on your picture because you forget. So I got -2/3. So again, tan of alpha in this time is equal to -2/3. Try to use different letters, so don't use theta more than once because that's not possible. Now if you shift tan -2/3, you're going to get a negative answer. So if you add 180, I get 146,3099. Oh my word, that's going to match. And therefore, if I subtract, if I say, I suppose I could do exterior angle. So I like to do exterior angle, so it means alpha is beta plus theta. So I could say that 146,3099, that's not 39, so let me take that away, is equal to 101,3099 plus beta exterior angle of triangle. Therefore, beta equals 45 degrees because I subtracted. I did a shortcut. I could have found this angle here using adjacent angles in a straight line and then sum of angles in a triangle. Now, the moment I got 45, I was like, oh, that was silly of me. Now, why is that silly of me? Because I should have known my properties of my square. And I hadn't drawn this in here, so I'd forgotten that I was working in a square. If I'd remembered that, I would have remembered that the corner angles are 90. And in a rhombus, all diagonals bisect corner angles. So these angles are always cut in half. So this always equals this in a rhombus. Now, in a square, which is a type of rhombus, your corners are 90. So when you cut it in half, you get 45. So if I'd remembered that, if I'd drawn in my square, I would have gone beta is equal to 45 degrees, one line, and I would have said diags of a square as my reason. Because diags of a square means I know the properties of my diagonals. It cuts the corner angle in half. So that was indeed a little silly, but good practice of our angles of inclination. Cool, I'm going to stop here because this is a long enough video and you need a break. And then we'll continue with example 3 and 4 in the next one. Okay, well done.